Okay, so I'm just going to recap your grade 10 here. In grade 10, you did solving systems of equations. Okay, but you only ever worked with linear equations. Okay, now I'm going to throw other things at you. So for instance, this is not linear anymore. What is the name of this function if it's not linear? Do you remember the name of it? Starts with a Q. It's a quadratic. Quadratic. Yeah, it graphs a parabola, but the name of the function is a quadratic function. This is a linear function. Okay, so in grade 10 you learned 3 methods. You could do substitution, elimination, or graphing. Okay, so substitution is making equal replacement. So if y equals x squared, could I go into the other equation and replace that y? Does that make sense? Okay, you can make an equal substitution. So if y equals x squared, okay, what I'm doing is I'm going to take, well, y is equal to x squared, so I'm going to replace that. That's a substitution. Okay, in order to pass grade 11, you got to know what to do with this. I want to hear 2 words from you right now. Equals 0. Those are my 2 words I want to hear, right? That's it. You got to equal 0. Whenever you have 2 separate variables, so x squared and x, those are different, you got to 0 it out. Okay, now I believe you would recognize, okay, what should I do now? I should factor, right? Okay, but that 0 thing is very important. You can't do the factoring stuff until it's a 0. Okay, so whenever we're solving a system of equations, you should understand your last step. No matter which method between substitution and elimination, your last step is always a plug-in step. Okay? So if x was 2, what would y be? Can you figure that out for me? You go back and plug it in. Does it matter where you plug it in? No. So for instance, if I plug it in here, what's 2 squared? 4. If I plug it in here, what's 2 plus 2? 4. So it doesn't matter where you plug it in. So if I plugged in a 2, I got a 4. And what if you plugged it into that one, though? Did you get 1? Positive 1. Okay, elimination. So we've been doing this one. So elimination is where we stack them on top of each other in columns and then eliminate something, right? Okay, I don't like this. Why don't I like this right now? I like having a y on top of a y. That's a column match. But here, there's an x squared with an x. Okay, I don't like that. So I'm going to change this. So can you visualize, like, I got some imaginary columns happening. Okay, so x squared. Okay, I'm actually going to put in, there's no x squareds in that equation at all. So I'm just going to kind of put a placement holder. What do you think I'm going to make my next column contain? X. So for this, there's an x. If I really want, I can put 0x there. kind of to understand there's no x's in that column. And then so if I really wanted to, I could understand that there's nothing there, nothing there, nothing there if I am matching it up. Okay, which variable do you want to eliminate? Or what do you want to eliminate here? I think the y's, right? I could get rid of the y's. So you're trying to eliminate something. What should I do to get it to go? Should I add them together or subtract them together? Subtract. Okay, so here we go. Y subtract y is 0. What is x squared subtract nothing? X squared. What is nothing subtract x? Minus x. And what is nothing subtract 2? Minus 2. Oh, guess what? I'm exactly there. Okay, so I'm not going to finish this out because once you got to this step, you would have done all the same things over here. I'm right here, so I would have factored and solved. Okay, but do you see how I used two different ways and I got to the same idea? Okay, we're going to graph. So first, what do I know about that? X squared. Somebody did say the P word before. Parabola. Okay, where should I start this parabola out? Where should I put it, the starting point of it? The origin, 0, 0. How do I make points going forward in this parabola? I'm going to do 1. If I move x1, I move y1. If I move x 2 positions, then y has to change by 4. If x moves 2, y moves 4. If x moves 3, then y moves 9. So there's y equals x squared. What do you know about y equals x plus 2? What does that look like? What kind of function is it? Linear. So it's going to make a what shape? Straight line. What are we doing? We're going to understand y equals mx plus b. So where should I think about starting this line? Y-intercept of 2. Remember that? Y-intercept. And this is telling me what to do with my rising and running. So I should go up 1, right 1, up 1, right 1. Okay, and I have a line. Okay, where did these lines intersect each other? 2, 4 was one coordinate, and -1, 1 was the other coordinate. Oh, look at that. Does that match our algebra? Okay, number 2. We are not going to do all the methods because you actually wouldn't know how to graph this. My grade 12s are going to learn how to graph that in advanced math. So you do not know how to do that. Which method do you guys want to do? Is there something we want to substitute, or is there something we want to eliminate? What do you want to do? Both methods can work. One would be easier than the other one. Eliminate, that would be the best. So if I could pick a strategy on this, I would have been picking elimination. Okay, is there any of the variables set up to go away right now in a column? Yeah. These are actually nicely set up for us already. So don't have to times them by anything, right? Sometimes we have to times them together to match. What do you want to do? Add or subtract them together? Add. Okay, if they're the same, subtract, S and S. But if they're not, those are opposite, so you add them. Okay, columns, ready? The first one would make 3x squared. The y squareds are gone. 27. Divide by 3. And the early morning test, did you get the correct answer to x? Positive or negative 3 would work. Remembering that? Because I could square 3, I could square negative 3. They both work. Okay? What's always your last step with equations? Plug-ins, right? That's always the system. You always have to plug in at the very end. Okay, which one do you guys want to work with? The first one or the second equation? It doesn't matter. You just kind of say which one maybe looks like easier math. I'm going to do the second one, so I don't have to do any subtracting. 2x squared plus y squared equals 22. Okay, so here I go. I'm going to go 2 times, I'm just going to put 9 in there. Why? Because x squared, why don't I just go right to this? X squared is 9. I don't need to fart around with doing 3 squared there yet or something. So just put 9 there. Okay, so this is 18. So if I subtracted 18, I would get 4. Y equals okay, so this is your answer. There's actually 4 coordinates that work. Okay, I'm okay if you leave your answer like this. I'm okay if you leave it like that, but here's what's actually happening. You have 4 coordinates that work. Do you understand that? Where is that coming from? You could have 3 and 2. You could have 3 and negative 2. You could have negative 3 and 2. Do you see the 4 combos that could happen? Okay, I'm going to show you why there's 4 coordinates. So this top shape is called a hyperbola. So this top shape makes a hyperbola. So when you graph hyperbolas, they're kind of like 2 sideways parabolas on that one. That's a hyperbola. And this one is an oval shape. It makes an ellipse. Guess how many times they intersect? They intersect 4 times. That's where it's coming from. Okay, so you don't need to know how to graph that. Okay, but I'm just showing you why did there happen to be 4 coordinates. Okay, number 3. Which method would be the easiest? Would anybody pick graphing as the easiest method? Probably not. So let's say it's between substitution and elimination. I'm going to pick substitution. Okay, I don't know why the equation's like this, so I'm going to revamp it here. I'm going to just change these equations. Why would we not maybe move this 70 over? Is that okay? Minusing 71. I'm also going to do that here. I'm going to revamp this. Okay. Y equals. So why can't I go like this? If y is equal to that, can I go and replace it? Does that work? So y is equal to this. I'm going to go over here and replace y. Okay, so that's the substitution. Algebra. This is not the equal 0. Why is it not an equal 0 style? There's only one variable in this, right? So then it's isolation. So collect, move, divide, right? So I'm going to go minus x squared as a first collection. Collect like terms. I'm going to do an add 70. Be careful with your squareds. Remember what to do. This could have been a positive or a negative 4. Okay, what do we always do at the end? Plug-ins. Okay, so you're going to have to do a plug-in for 4 and for negative 4. Okay, where do you guys want to do plugins? I can tell you where my easiest spot I would pick. I would pick, this looks like my easiest spot to pick, right here. Okay, so out of these 2 originals, remember we just kind of moved them around. This one looks easiest to plug in. Okay, here we go. What is 4 squared in your head? 16, subtract 6, 10. And this is actually also 10. Okay, if I was to graph these 2 and see their intersection, what kind of shape is this one? Parabola. What kind of shape is this one? Parabola. They're both parabolas. So this is your visual of what happened. There was 2 parabolas and they intersected at 410 and negative 410. They intersected, okay?